This section, we are going to learn how to solve the system of linear equation using the inverse matrix. In the previous lecture, we learned that when we have a system of linear equation like this system, we can actually convert this system of linear equation into the matrix form. So how do we do that? First, we are going to take the coefficient of the variable. So these are the coefficient of the variable, right? The coefficient for x, right? So this is 1. All right, so 2, negative 3, and 1. So make it the coefficient of matrix, right? Then we have negative 4, 6, negative 3. So form another column of matrix here, and 1, negative 5, 7, right? Another column of matrix here. So we take the coefficient of the variable to form a matrix and let it be the matrix A. And after that, we are going to take the variable x, y, and z to form a column matrix. Alright, and we let this matrix be matrix X to represent this is the matrix for the variable. And for the answer on the right hand side of the equal, we form another column matrix. Now, according to the multiplication operation in matrix we have learned before, now when we multiply A to X, so we will get equals to B. All right, and when we perform the multiplication, we will get back the system of linear equation. All right, we have 2 times x, all right, negative 4 times y, and 1 times z equals to 6. So we get the first equation. All right, then if we use negative 3 times x, 6 times y, negative 5 times z, get this, equals to negative 1. So we get the second equation and so on. Alright, so we have learned how to convert the system of linear equation into the matrix equation. So for this section today, we are going to learn how to use the inverse matrix method to solve the system of linear equation. Now, to solve the system of linear equation, we must first find the inverse matrix. So this is very important. We are going to explain what is inverse matrix later. Now, in order to find the inverse matrix, we have to do these 4 steps. Right, first we need to find the minus and the cofactor of the matrix. After that, we need to find the determinant of the matrix. And we need to find the adjoint of the matrix, and after the first 3, then only we can find the inverse matrix. Right, we are going to talk about this one by one. Now let's start with the minor and cofactor of the matrix. Right, now if A is a square matrix of order 3 by 3, right, the minor of Aij denoted by Mij is the determinant of the 2 by 2 matrix obtained by deleting the ith row and jth column. Now what does that mean? Alright, so let's say we have a matrix A here. Alright, now to find the minor for this element, right, this element we call this A11. What does that mean? It means that this is the element for first row, the first column, right? So this is how we denote the symbol, right? We denote this as A11, right? The element for first row, first column. So to find the minor for this element, so this is what we are going to do. We will actually delete this row. We delete this column. Alright, so now after we delete the row and the column, So we have a smaller matrix here, 2 by 2 matrix here. All right. So we are going to use this matrix 6, 5, 8, 7 to find the determinant. Okay. So this is what we do. All right. Now the minor, this is the symbol we use. We use M. 1, 1 again represent the first row and the first column. So the minor for the first row and the first column, we are going to delete the first column and the first row. And for this 2 by 2 matrix, 6, 5, 8, 7, so this is what we are going to do. We will take 6 multiply 7. 6, 7 is 42. Then we minus 5 times 8. 5 times 8 is 40. So we get 2. So this is the minor for this element. All right. Now, how about the minor for 3, 2? All right, the minor for 3, 2, row number 3, column number 2. So it will be row 1, 2, 3, this row, the second column. So this is the element. All right, this element is denoted as element 3, 2. All right, the element 3, 2 here, all right, we are going to find the minor. So what do? We are going to delete the row and delete the column again. So we can find a smaller 2 by 2 matrix, 2, 1, 4, 5. All right, so then this is what we are going to do again. We will take 2 times 5, so it's 10. And then 4 times 1, which is 4, and we subtract. So 10 subtract 4 is 6. All right, now to find the matrix for second row, third column, right? So second row, where is it? Second row is here. Third column is here. So this is the element, second row, third column. So the element is 5. To find the minor, we delete the row and column. So we have 2, 3, 9, 8, and 2 times 8 is 16. 9 times 3, 27. So 16 minus 27 is negative 11. So these are the minor for the respective elements. Okay, now how to find the cofactor then? Now to find the cofactor, we apply the sign positive and negative to the minor. So the sign are distributed always in this form, alternately one positive, one negative, one positive, one negative. Right, start with positive. So the sign of the cofactor is always distributed in this way. All right, now, so back to the first one. All right, now to find the cofactor for first row, first column. Okay, so we are going to apply the sign. So what is the sign? The sign is positive for this one. First row, first column. So we have first row, first column. The sign is positive. So we multiply the positive, the sign, to the minor. The minor is 2. And so we have the cofactor is 2. Now, for cofactor 3, 2, right, for the cofactor for this number, this element, the minor is 6, right? The sign is negative. So we are going to multiply the negative with the minor 6, right? So negative is here, and the 6 is here. So therefore, the cofactor is negative 6. Now, as for the cofactor, second row, third column, right? That's one, second row, third column. Now we know that from here the minor is negative 11, right? So the minor is negative 11. And the sign will be, so we refer to this sign again, right? Second row, third column, the sign is negative. So we apply the sign here, multiply with negative 11. So the cofactor is 11. Alright, so these are the example how to find the minor and the cofactor for some of the elements in matrix A. Now we can actually find all the minors and cofactor for the 9 elements here. Okay, so it is possible to find all the cofactor and the minor for all the 9 elements. Okay, now let's try this. Okay, find all minors and cofactors of the elements for this matrix A. Right, so the answer is given here. So you can actually try to do this. Right, now, so we are going to start with the cofactor. So I'm going to combine all the sign together with the minor. So this is what we do. First, we are going to find the small matrix, all right? So we are going to cancel, delete the first row, first column. So we have 1, negative 3, 0, 4, 1, negative 3, 0, and 4. All right, so this is the minor. Now, how about the sign? The sign is actually 1 positive, 1 negative. All right, so therefore, for this sign here, so the sign is a positive sign. So I'm going to put a positive here. All right, so this is the positive multiply the minor. So we can proceed to the cofactor C12, so which is, right, delete the row and the column. We have 2, negative 3, negative 2, 4. Right, delete the row, delete the column, so we get this. All right, so then the sign is negative. Okay, and then the third one, so delete the row, delete the column, so we have 2, 1, negative 2, 0, and the sign is positive. All right, so continue with 2, 1. Okay, so we delete the row, delete the first column. We have negative 1, 0, 0, 4. All right, 2, 2. Okay, we delete the second row, second column, 3, 0, negative 2, 4. Okay, so we have then the second row, third column. Okay, so second row, third column, it will be delete the second row, delete the third column, 3, negative 1, negative 2, 0. Okay, now then we apply the sign. This is negative, positive, and negative. All right, now you can actually apply the sign after you find all the minor. That should be okay. Then we have the third row, the first column. All right, so third row, the first column. All right, we delete the first row and the third column. So we have negative 1, 0, 1, negative 3. All right, so then we have 3, 2. All right, so we have K. Again, we delete the third row, the second column. It will be 3, 0, 2, negative 3. Right, and then we have third row, third column. So delete the third row, the third column. So we have this 3, -1, 2, 1. Alright, so the sign will be positive, negative, and positive. Okay, now after that, right, so we proceed to do the calculation for minus 0. So this is what we get. We get 4. Alright, and how about this one? We have 8 minus, this is 6. Alright, and the whole thing is a negative. So we have a -2 here. Before that, alright, so let me make a divider here. Make a divider here. Okay, and okay, let's come back to this one. So then here we have 0 minus -2. So we get 2 here. Alright, so then for this one, we have a negative. Alright, negative, then this is -4 minus 0. We get 4. Right? And for this one, we have 12 minus 0. And we have a 12 here. And then for this one, we have 0, 0, minus 2. And we have 2. Alright, for this, we have positive 3. Right, -1 times -3, which is positive 3, minus 0. So, which is 3. And for this one, we have -9. Alright, minus 0. And a negative in front here. So, we have a 9 here. And for the last one, we have 3 minus -2. Alright, so 3 minus -2. That is a positive in front, so it doesn't make any changes. So it will be 5. Alright, so finally we have all the cofactors. 4, -2, 2, 4, 12, 2, 3, 9, and 5. So this is how we find the cofactor.